If you're a software developer or architect, sometimes you're going to have to describe to technically minded people that aren't developers, such as a project manager or a requirements analyst, how the software will work. They'll need context so that they can describe the acceptance criteria or reason about breaking down the tasks in the build order. A data flow diagram is just at the right level of granularity for those individuals, and that's what we're going to be talking about today. The topics we'll cover are that we'll describe what a data flow diagram is and the building blocks in a data flow diagram. We'll talk about what one of these things is useful for. I'll describe how to make one, and then I'll show you some example diagrams, and then finally we'll summarize. A data flow diagram is a visual model of a system and its data flows. There are a variety of notations that you'll see out in the wild, but essentially they are built out of four main building blocks: external interactors, or those things that interact with your system and which are generally considered to be outside of the system, such as end users. Processes, in other words, things that are within your system that operate or process the data. Data stores like databases or files, which basically represent places that your data can stay at rest. And data flows, which are the directed transactions between the other kinds of entities that we've already talked about on the diagram, like the data stores and processes. And these represent the path or the paths that your data can take through your system. A final part, which you'll often see but it's not necessarily standard, is a boundary. And you can draw a boundary for a bunch of different reasons, and I've listed some here. Basically, it's a line around a set of processes and data that represent the limits of your system, application, process, network, or parts of the environment that you can trust on. A data flow diagram is useful for reasoning about data transit, formats, or encodings. It's useful for reasoning about data storage and processing requirements. They help you decide how to break down work, describe dependencies between that work, which helps you to communicate build order of a feature or suite of features. It's useful for threat modeling, and in the past I've used the Stride threat modeling process, which lets you label each of the building blocks in your system or on your data flow diagram with attack vectors. Stride is actually an acronym for spoofing, tampering, repudiation, which is where somebody claims they didn't do something, information disclosure, denial of service, or elevation of privilege. So it's useful for that. And finally, a DFD is a useful precursor to a finer grained modeling technique like a sequence diagram, a deployment diagram, or a class or object diagram. So how do you make a DFD? Well, you start with a coarse DFD and you break process and data stores into smaller parts. If you have a use case diagram, you can start with that by putting the users on the use case diagram as external interactors on your DFD, and the processes and the use cases, and turn them into processes. And then you can start by taking your external interactors and your data stores and trying to fill in the data stores, data flows and processes, data stores in between. Some good rules to follow is that no data should come from nowhere. In other words, they should probably come from an external interactor. So perhaps it's a config file and a developer put it there, but it's worth considering. And again, data should also go somewhere. In other words, if it comes from the outside and is stored in a data store, then what's the point of it if it's stored in the data system and doesn't come out again? You might, for example, have a log file that gets written, and perhaps it's worthwhile modeling that the developer comes in and picks it up sometime. And ideally, you wouldn't have any direct links between external interactors and data stores. It just makes common sense that you don't directly interact with your database. Instead, it comes via some process in your application. Once you have some interactors, data flows, processes, and data stores, you can draw some lines around subsets of the diagram to indicate physical or logical boundaries in your system. So here are some examples of data flow diagrams. The first one here depicts the process of responding to a web request. You can see a user there, which is an external interactor. You've got three processes there, an authentication one there at the top, an authorization one, and processing the request itself. There are a couple of data stores there, and there are some data flows between the data stores, data flows, and the external interactors. And there are two boundaries there that represent a physical and a logical space in the DFD. Here's a second one, which is more physically focused. We have processes that exist on specific hosts, and we have some labeled data flows there with metadata about the protocols used. So to summarize, data flow diagrams are a way of explaining or reasoning about system components, including who will use it, what it will do, what the processes will need, and how the processes get or transfer the data. You can use them as a basis for breaking down work into those components in particular. What are the components? What are the protocols and the formats used by the components or controls there? And as a next step, you might turn your data flow diagram into a component or deployment diagram, an entity relationship diagram, a sequence diagram, a class or object model, or this might be enough detail, depending on the size of the process that you're building. It might be enough detail that you can start writing user stories and acceptance criteria and use this diagram as a figure in the story to show some context. If you'd like to talk more about data flow diagrams and how you can use them and incorporate them into your design and architecture process, my details are in the description. Hit me up. Thanks for watching.